Let us see this question. CDE is an equilateral triangle. CDE is an equilateral triangle formed on the side CD of a square ABCD. So ABCD is a square given for us, right? And also mentioned that CD is an equilateral triangle. Now what is asking you to prove? Is asking you to show that triangle ADE is similar to triangle BCE. So first let us start with the given condition. So given part. What can you write in this given? CDE. Okay, triangle CDE is an equilateral triangle. Equilateral triangle. And also what else is mentioned? It is given that ABCD is a square. So what I have to prove? I have to show that triangle ADE is congruent to triangle BCE. This is what we have to prove it. Okay. Now let us start the proof for this. So when you start the proof for this, first let us start with the given conditions itself. What he told, triangle CDE is an equilateral triangle, right? Equilateral triangle. So that means I can use the word that CD equal to DE is equal to CE, and also angle CDE, this part, angle DEC, this one, and is equal to angle ECD is equal to 60 degrees because it is an equilateral triangle. Okay, so triangle is equilateral, we got up to here. Now similarly we can take the concept of even square also, right? So what is that? ABCD is a square. So since it is a square, all the four sides are equal. I can write that AB equal to BC equal to CD equal to AD or DA. Right? All the four sides are equal, and similarly all the angles also will be equal. Right? That is equal to 90 degrees. So I can write here as angle ABC equal to angle BCD equal to angle CDA is equal to, right, CDA and angle DAB. All the four angles will be 90 degrees each because it is a square. So that means when you mention in the figure, you can tell that this part, this 4 are 90 degrees. Okay, so you got up to here. This concept is clear for this. Okay, now. So these parts are equal. These two sides and similarly these sides. Right. Now consider two triangles, triangle ADE and triangle BCE. Okay, now we will start with this part. Consider triangle ADE and triangle BCE. Right, AD equal to BC, sides of a square. AD equal to BC equal, since they are sides of a square. Right. Similarly, DE equal to CE, sides of an equilateral triangle. Right. These two are done. Now, angle ADE, this angle, and we will see angle BCE, this angle. Now, if you see here, angle ADE is equal to, is a combination of two angles, angle ADC and angle CDE, right? Is equal to angle ADC plus angle CDE, that is ADC, that is 90 degrees, plus CDE, that is 60 degrees. So totally this is 150 degrees. Right. Similarly, angle BCE, angle BCE is equal to, this is also the combination of two angles, angle BCD and angle DCE, right? Angle BCD, BCD plus angle DCE, DCE, DCE is equal to, BCD is the angle of square, so 90 degrees, plus DCE is the angle of an equilateral triangle, so 60 degrees. So this also you got it as 150 degrees. So therefore angle ADE is also equal to angle BCE, equal to angle BCE, right? So here you can see two sides and the corresponding angle. So therefore by SAS congruency, okay. So by SAS congruency, what can you tell? You can tell that triangle ADE is congruent to triangle BCE. This is what we have to prove it. I hope you got the solution here.